I have a Generac generator 5000 watt. I get no power out of it. I have pulled the end plate and unplugged the harness. I have 3 wires, a blue, a red and a gray. I get no voltage between the red and gray and no voltage between the blue and gray. What excites this unit?
Hi, I'm a moderator for this topic and I wonder whether you're still waiting for an answer. If you are, please let me know and I will do my best to find a professional to assist you right away. If not, feel free to let me know and I will cancel this question for you. Thank you.
I am still waiting for an answer. Thanks, Gerry. You said he needs more info. Please tell me what he needs. Thanks, Gerry. Still waiting.
Hello. Thank you for choosing JustAnswer for the solution to your problem. My name is XXXXXXXXXXX. I am going to assist you with this. What is the model number of the genset?
Generac model 01658, serial number XXXXXXXXXX 5000 watt Briggs engine. The generator itself is a Synchro type EP295L generator. That is the #XXXXX the tag. Are these the numbers you are looking for?
Sorry, I was at work when you replied. I worked second shift. Yes, these are the numbers I need. This is a self-excited unit. Here is a brief description of how it works. A genset is composed of 2 major components, an engine and a generator, commonly referred to as an alternator. A generator is composed of 2 major components, a rotor, commonly referred to as an armature, and a stator. The stator typically has 2 or more windings, 1 or more power windings, and a smaller exciter winding. There are 3 things required for the production of electricity: a magnetic field, a conductor, wire, and movement between the field and conductor. Since the field has no physical mass, it is much easier to move it than to move the conductor. We move the field by spinning it with the engine. This is why most gensets are known as revolving field gensets.hf. When you start the engine, the rotor starts spinning. It is connected directly to the crankshaft of the engine. The rotor is a giant electromagnet. When not running, the rotor retains a small bit of magnetism, known as residual magnetism. As it spins, the magnetic field around the rotor is passed through the windings of the stator, conductor. The magnetic field aligns the electrons in the wire and makes them move. This flow of electrons is electricity. Residual magnetism will create a residual output voltage of about 3 to 6 VA at the receptacles. However, the amount of electricity flowing is not very much, so a capacitor in the field windings, rotor, stores an electrical charge to increase the voltage to the field. This charge goes through a diode, which converts it to a DC current, and feeds it back to the rotor. This increases the strength of the magnetic field, which, in turn, increases the amount of electricity produced. Remember, a magnet has 2 poles, north and south, or positive and negative. As the positive pole passes the windings, it moves the electrons in one direction, the positive pulse. As the negative pole passes by, it moves the electrons in the opposite direction, the negative pulse. One positive pulse and one negative pulse are 1 cycle, or Hertz. Since US power is 60 Hertz, this process must happen 60 times per second, 50 times per second, 50 Hertz, in much of the world. HF we now have nominal voltage flowing, 120 V in the US. HF what can sometimes happen is that the rotor loses this residual magnetism, and it must be restored. Here is how to do that. To restore magnetism, 1. Remove the spark plug wire, you do not want the engine to start while doing this. 2. Obtain an old extension cord that you can cut one end off, or an old power cord from an appliance, you will need the male end left on the cord. 3. 4. Note how on the receptacle, one slot is longer than the other. This longer slot is the negative slot. It is critical that you get it hooked up correctly. 5. Determine which wire of the cord will go to the negative slot. 6. Connect the negative wire to the negative terminal of a 12 volts battery. 7. Connect the positive wire to the positive terminal of the battery. 8. Plug the cord into the receptacle and pull the starter cord 6 to 8 times. 9. Immediately unplug the cord. Do not leave the cord plugged in for more than 6 or 8 seconds. 10. Disconnect the wires from the battery. 11. Reconnect the spark plug wire and see if the set is now producing electricity. If it is not, please let me know and we can troubleshoot further.
I tried that, it did not charge yet. What else can I do? Thanks, Gerry.
Next, remove the end cover of the genset. Of the 3 wires that come out of the stator, red, blue and gray, let's test to see if any of them are bad. Disconnect the plug that holds the wires. At the end of the plug that leads back inside the genset, not up to the receptacles, set your meter to ohms. Test across the following pairs of wires, and you should get the following results: blue to red 0.93 ohms, gray to red 0.93 ohms, blue to ground infinity, gray to ground infinity. What do these read?
First I hook my ohm meter leads together and set meter to 0, it says to set ohms. When you hook the leads together that would be infinity. Then blue to red goes to 0 or infinity, then gray to red goes to 0 or infinity, then blue to GRD nothing, then gray to ground nothing.
When you connect the leads together, and the meter goes to 0, this indicates full continuity, or zero resistance. Infinity would mean that the needle would not move at all, like the leads are not touching. But you are using an analog meter, and it will not work on such low resistance. You have to use a digital meter to measure this, an analog is just not sensitive enough. But if you are reading zero resistance, very low, the problem is most likely not a bad stator. The problem now is probably in the rotor. There are a few components inside the rotor: diodes, varistors, and capacitors. Unfortunately, to test them, they must be removed from the rotor. They are soldered in, and unless you are experienced with detailed electronic soldering, this is not something you should attempt yourself. Don't even do that. I take these types of rotors to an electrical shop for testing. I would highly suggest you take the rotor to a shop that rebuilds electric motors to let them test it.
How can I test the capacitor? Could this be the problem?
Yes, the capacitor could easily be the problem. There is no realistic way to test it without a special capacitor tester, which any electrical shop will have. Take it out, and take it to an electrical shop to have it tested. Let me know how it turns out.
If you have a home improvement or appliance question and want to chat with an expert, now visit justanswer.com/ythi.